Okay, the purpose of this video is to explain what the domain of a rational function is. Before I do that, I want to just explain fractions, normal fractions as you know them. So for example, if I write a fraction, let's say 5/2, you can calculate what this fraction is. So this is okay. If I write a fraction, let's say 1.7 divided by, say, 18, this is okay. You can calculate what this is. If I write down a fraction that's, say, 0/27, okay, this is an easy one. You can calculate what this is. But if I write down a fraction that's, say, 5.2 divided by 0, then we're in trouble. This is undefined. This is an undefined fraction. And if I write down even, let's say 0/0, this is also undefined. And in general, a fraction, let's say p/q, this is defined. Well, we can calculate it if q is not 0, basically. So if q is not equal to 0, and it's undefined if q is equal to 0. Okay, so we understand this, how to calculate fractions and when they're defined. So we can use this intuition for understanding what the domain of a rational function is. So what is a rational function? It's a ratio of two functions where each of the two functions is a polynomial. So I have a ratio of some polynomial p of x and some polynomial q of x, and I take their ratio. And so what does this machine f do? So if I think about this as a function machine, I input my x, and something happens in here. What happens? You can sort of think of it as three things happening, right? X goes into, let me explode this machine and look what's happening on the inside, right? So X goes into the P of X machine, and some number comes out, P of X. X goes into the Q of X machine, and some number comes out, Q of X. And then we divide these two numbers. So we take P of X over Q of X. So what's happening in here is some number is going to come out of the first polynomial. Let's call that P. And some number is going to come out of the second polynomial. So let's call that Q. And so for every input X, what I get is a fraction, right? And now we understand when fractions are defined. So we can say, when is this going to make sense? So when is this going to pop out a number that we understand, and when is this going to pop out something undefined, or when is it going to break the machine? When are we not allowed to plug this into the machine? And since this output is just a fraction, we can just apply the rules of fractions that we just talked about. So this is some P of X and Q of X. And this makes sense if Q of X is not 0. And it's undefined if Q of X is equal to 0. And so what does that mean? That means that the domain of f is all x such that Q of X is not equal to 0. So let's just do an example. If f of x was x cubed plus 7x plus 3 divided by x minus 1 times x minus 2, then if we plug in an x value, if the denominator is non-zero, then this will make sense and we'll get an output. If the denominator is 0, then what we'll get is an undefined number, so it won't be in the domain. So the domain of f in this case is all x that are not 1 or 2, because if we plug 1 in here, we'll get 0. If we plug 2 in here, we'll get 0. But every other x, if I plug in anything else, then this denominator will be non-zero, and so I'll get a well-defined fraction.